So we have talked about how to solve, that's interesting. We've talked about how to solve quadratic equations. How do you tell if an equation is quadratic? What's that? It's got an x squared in it, okay? So we talked about one way to solve them when you have x squared and a number, where you get the x squared by itself, you take the plus or minus square root. But not all quadratic equations are like that. Sometimes they have three terms, like this example that you see here. We can't just put the 9x and the 20 over to the other side and take the positive and negative square root, because we'd still have an x over here. It wouldn't make any sense. We wouldn't get a numerical answer. So we need a different method, and we use factoring. But before we use factoring, there's a certain product or a certain property that you need to know to help you solve these by factoring. So if the product of two numbers is 0, we can say at least one of those numbers must be 0. Because the only way you can multiply two numbers and get an answer of 0 is if one of the numbers is 0. At least one. They could both be 0. So in math speak, I'm about to say the same thing. If some number A times some number B equals 0, then either A equals 0 or B equals 0. That's the zero product property. And we use it, like I said, to solve quadratic equations by factoring. So to solve a quadratic equation by factoring, okay, first thing we do, make sure all terms are on one side of the equation. With 0 on the other. On the other side. Factor the expression that's all by itself on one side. Three, set each factor equal to 0. To find your solutions. Or roots. Remember, we said roots is another word for solutions. Okay? That's the method. And we'll do some examples. Hopefully you'll see how it works. Give you a chance to get that down. Okay. All of these types of questions, equations, will have an x term, which means we can't use the positive, negative square root method. We have to get everything to one side, factor, and then after we factor, we still have work to do. We have to solve. So are all the terms on one side in A? with 0 on the other? Really? Or all the terms on one side, 0 on the other? Yes. So that's taken care of that. That's taken care of, step 1. We didn't have to do anything. Step 2 is to factor this. So now you got to know your factoring. What kind of factoring is that? GCF. So what can I take out? And what is the other factor when I take out x? Excellent. Don't forget to add that equals 0. That's important because we've got equations now. Now remember the zero product property. If we multiply two things together and get 0 as an answer, then one of those things must be 0. Which means this could be 0 because 0 times whatever this is 0. And this, whatever makes this 0, times this will also be 0. So what will make this factor 0? This is not a hard question. This is an easy question. Don't overthink. What could I plug in here to make this 0? What could I plug in here to make this 0? Do I plug 1 in here and it'll be 0? What do I plug in here? 0. That's one of my answers. The other answer is whatever makes this factor 0. So what value of x would make x plus 7 equal 0? Negative what? Negative 7. You just solve. These are my two solutions. So if you've got an x by itself as a factor, one of the answers is always going to be 0. Always. Okay? And we can see that this works because 0 squared plus 7 times 0 is 0 plus 0, which is 0. So this works. Negative 7 squared is positive 49. 7 times negative 7 is negative 49, and 49 minus 49 is 0, which means this also works. So you see that we now, with these quadratic equations, a lot of the time we're getting two answers now. Whereas in grade 9 and grade 10, when we were solving linear equations, we only got one answer. So again, just ask yourself the steps. Is everything to one side and 0 on the other in B? Yes. Now factor this. It's a trinomial. It's an x squared trinomial. So it begins with x, and the numbers will have a sum of negative 6 and a product of positive 9. What two numbers multiply to get positive 9, but add to get negative 6? Negative 3 and negative 3, so they happen to be the same. Don't write x minus 3 squared here. Leave it like this when we're solving. So now I ask myself, okay, what value of x will make this factor, x minus 3, equal to 0? 3. That's the solution. Won't this be the same thing? This will be also 3, right? So I don't need to write 3 twice. So in this example, there's only one solution, 3. And if you tried it, 3 squared minus 6 times 3 plus 9, if you calculate all that, you'll get 0, which is the right side. Okay? Try the next one on your own. See if you can do that one. Remember, after you factor, you're not finished. You have to actually go to get the solutions after. So are all the terms on one side with 0 on the other? Yeah. So I'm ready to factor. Remember, don't forget to write the equal 0. So what is this in factored form? Anybody? X plus 7 times X, and then I heard minus 2. Good. And now, this isn't like, we're not done yet. This is the form where we find the answers. So what value of X would make this whole thing work out to 0? Well, you could probably do this in your head. -7. It's always the opposite sign. But here's how we do, like we just say, okay, what value of X will make X plus 7 equals 0? X equals -7. That's one solution. What value will make X minus 2 equal 0? What's that one? 2. The majority of solving quadratic equation by factoring questions will involve GCF and X squared trinomial factoring. But you will sometimes get the AX squared. Are all the terms on one side with 0 on the other? Yes. So we're ready to factor. This is an AX squared trinomial, but we still write 2 sets of parentheses. And now we've got to figure out the factoring. So this is the one where we put in terms here that we know multiply to get 2x squared. What times what is 2x squared? Yeah, so we know it's got to be 2x and x. These will multiply to get -5. Plus 1 minus 5. So that works. But then I have to check to see if the middle term works if I were to multiply this back. How do I check the middle term? The outside product, -10x, plus the inside product, plus 1x, does in fact equal -9x. So that is the correct factored form of this trinomial. And now to get the solutions, set each of the factors equal to 0 and solve. So what value of x will make 2x plus 1 equals 0? Well, how do we solve this? It's a two-step equation. Really? We divide by 2 first? Sorry? Speak up! What's that? Thank you. Subtract 1 from both sides. We always get rid of what's furthest from the x first. Come on, you guys. This is grade 9 stuff. So 2x equals -1. Then we divide both sides by 2. X equals -1/2. That's one answer. The other answer will be whatever value of x makes the second factor, x minus 5 equals 0. What's x here? 5. There's our two solutions. -1/2 works, so does +5. Okay. Oh, we got another one of these. See if you can factor this one. And then solve from there. Anybody got it? Go ahead. 5x minus 1, x minus 3, okay? So 5x times x is 5x squared, yep. Negative 1 times negative 3 is positive 3 at the end, yep. Outside is negative 15x when we multiply. Inside is negative 1x when we multiply, and when we add those together, yep, so it's factored correctly. Remember, we're not done yet. Now we've got to set each factor to 0 and solve for each. So this one, I add 1 to both sides first, and then divide both sides by 5 to get x by itself, so x equals 1/5 here. This one, I just add 3 to both sides, x equals 3. So my two answers, my two solutions, or my two roots are 1/5 and 3. How about this next one? What do we need to do first? Yeah, we need to bring this over to this side, because not all the terms are on one side with 0 on the other. So I need to bring it over by adding 28, which means I add 28 to this side. So I get x squared plus 11x plus 28 is equal to 0. Now I'm ready to factor. It's an x squared trinomial. Which means we know it's x and x, and we're looking for numbers that add up to 11, but multiply to 28. And those would be? Think of two numbers that multiply to get 28, then add them. 4 and 7. Set each one equal to 0 and solve. So the first one, x will be negative 4. And the second one, x will work out to negative 7. Yeah. You mean if you didn't write this, if you went straight to here? No. Yeah. Usually, if it's these ones, you can do them in your head. These ones you may have to write out. No, I wouldn't give you the indication. Yeah, because you should reach the point where you can do them. Well, this next one's an interesting one. What's missing from this one that was in all the other ones we've done? Yes, or an x term, right? Don't we know how to solve these things when there's no x term? Don't we just get the x squared by itself and take the positive and negative square root? So be careful. All you have to do with this one, you don't have to factor. Come on. You don't have to factor. If it doesn't have an x squared term, bring the minus 25 over to the other side. Take the positive and negative square root of both sides, and that will leave you with x equals plus and minus root 25, which means x equals plus or minus 5. So be careful, because you're going to see a mix of them now. If there's no x term, do the plus minus square root thing. Factoring would work in this one, but it doesn't work all the time. I mean, well, I shouldn't say that. It's just, it becomes complicated, which is why I stick to the positive and negative square root. How about H? What do I have to do first? Yeah, I got to move the X over to this side. So I've got to subtract X, subtract X. So I get X squared minus X is equal to 0. It's got an X squared term and an X term, which means I have to factor. I can't do the plus minus square root thing. I can only do the plus minus square root thing when there's an X squared and a number. So what kind of factoring? It's not a trinomial. It's what? GCF? I heard somebody say? Yes, GCF. Because this is not a perfect square. Nothing times itself gives you X. So you can't factor it that way. So the only way is GCF. So we can take out an X, and the other factor will be X minus 1. When an X is by itself, it's really easy. What's the answer? X equals 0. That's it. You don't have to do any work. If it's got a number with it, then you got to set it equal to 0 and solve for X, or do it in your head, and you get X equals positive 1. So 0 is a possible answer, so is 1. And that makes sense because 0 squared is equal to 0. 1 squared is equal to 1. Both of those work. Okay. Put this one. What do we have to do first? Do we have everything on one side? No, we got to bring these over. I got to bring the 8 over by subtracting 8. And I got to bring the negative 2x over by adding 2x. So when I do that, well, the 3x squared is still there. When I bring the minus 2x over by adding 2x, it becomes plus 2x on this side. When I bring the positive 8 over by subtracting 8, it becomes minus 8 on this side. Notice I put it in the order that I can factor it. And we've got one of these ax squared trinomials again. Well, 2 sets of parentheses equal to 0. What must the first 2 terms of each be? 3x and x for sure. Now the numbers have to multiply to negative 8, so I've got lots of choices. Okay. There's actually a couple of pairs of numbers that multiply to get 8. 4 and 2 and 8 and 1. But remember what I said, always try the ones that are closer to each other first. So let's try 4 and 2 with one of them being negative. So I'm just going to try plus 4 minus 2. So I know that works. Now I have to see, I get negative 6x on the outside, positive 4x on the inside, which together make what? Negative 2x. But I need positive 2x. What's the mistake I made? Switch just the signs. Because I got the right number, I got 2x. I just got the wrong sign. So this is not the correct factored form. If I switch the signs, that will get me the correct factored form. Whoops. 4 x plus 2. So that's wrong, but that is right. Remember, we're not done yet. So I have to set 3x minus 4 is equal to 0. What does x work out to when I solve 3x minus 4 equals 0? X equals 4 over 3. Thank you. And when I solve x plus 2 is equal to 0, what is x? Negative 2. So my two solutions are positive 4/3 and negative 2. How about this next one? Look at it carefully. Farida? You want to take away 7 from both sides? Okay, so you're going to do it a slightly different way. Okay, good. So, but you are right. You could do it the other way. So there's no x term. There's just x squared and numbers, which means get the x squared by itself, take the plus and minus square root. So make it x squared is equal to 11 by adding 4 to both sides. Take the positive and negative square root of 11 to find x. Remember, we don't use our calculator. So we either leave it as a square root or we simplify it if there's a perfect square that goes into it that I can simplify it to. But there's no perfect square. So I'm done. Okay. Remember, no x term, do the plus minus square root thing. And finally, everything on one side? Yep. What can I take out? 3x? Like, what's different about this one than... What's that? Well, we don't have to move anything, but we have to start factoring. The question is, how do we factor it? Like, what's throwing you off here? This is throwing you off. If this is negative, take out a negative. Normally, we would take out 3x. Agreed? Yes? But because of this, I'm going to take out negative 3x. That's going to be my GCF. So what's the other term? What is negative 3x squared divide negative 3x? X. What is 9x divide negative 3x? Excellent. If you didn't take out the negative, then you'd have a negative inside here, and it could make things a little complicated. So if that x squared has a negative in front, factor out a negative as part of the GCF. And so the last step here is just make each one equal to 0 and solve. So if negative 3x is equal to 0, what's x? How do I get x by itself? Come on, you guys, this is a simple equation. How do I get x by itself? Divide negative 3, divide negative 3. So this becomes x, and what's 0 divide negative 3? Still 0. What does x work out to in this one? 3. Good. Okay, so we're going to stop there because the next step, which we'll do tomorrow, is we're going to do a few word problems using these things, much like we did with maximum minimum word problems. But these are different, and we'll talk about that. Okay? But like I said, in the meantime, for Monday, exercise 3.3. And you probably want to get a few of these questions under your belt this class, just so you're comfortable with what you're doing. Okay?